Welcome back to For the Mariners by the Mariners channel. In the modern era of smart shipping, the ability to interpret engine condition monitoring data has become the cornerstone of proactive maintenance and operational reliability for any vessel at sea. Gone are the days of relying solely on fixed maintenance intervals. Instead, marine engineers now use a wealth of real-time data to predict failures before they occur and optimize the performance of the main propulsion plant. The process begins with the collection of high-fidelity data from a vast network of sensors, measuring parameters such as cylinder peak pressures, exhaust gas temperatures, fuel injection timing, and scavenge air pressure. These individual data points are the vital signs of the engine, and when analyzed collectively, they reveal a comprehensive story of the internal health of the machinery. For instance, by monitoring the deviation in exhaust gas temperatures between cylinders, an engineer can identify a fouled fuel injector or a leaking exhaust valve long before it triggers a high-temperature alarm. Another critical aspect of data analysis is the study of the Pmax and Pcomp values, which represent the maximum combustion pressure and the compression pressure within each cylinder. When these values are plotted over time, they allow for the identification of worn piston rings or liner wear. Modern analysis also incorporates sophisticated vibration monitoring on turbochargers and main bearings, where changes in frequency spectra can signal a developing imbalance or bearing fatigue. This data is often fed into a centralized power management or engine control system, where algorithms compare the current readings against the engine's shop trial baseline or the digital twin model. One of the most powerful tools in an engineer's arsenal is the trend analysis, which looks for subtle shifts in data over weeks or months. A gradual rise in the specific fuel oil consumption while maintaining the same power output is a clear indicator of declining engine efficiency. Efficiency decline could be caused by anything from hull fouling to a dirty turbocharger air filter. Furthermore, the integration of lube oil analysis data into the monitoring platform provides a chemical perspective on the engine's health by tracking the presence of wear metals such as iron, chrome, and aluminum. This multi-dimensional approach to data analysis allows the crew to transition from reactive repairs to a condition-based maintenance strategy, which significantly reduces the risk of expensive downtime and catastrophic mechanical failure. Effective data interpretation also plays a vital role in environmental compliance, as it ensures the engine is operating within the optimized parameters for minimum nitrogen oxide and carbon dioxide emissions. If you found this video helpful, please give us a thumbs up, hit the notification bell, comment, like, share, and subscribe for more insights. Thank you.